All right, guys, welcome to this page of the notes. And what we're going to do here, before I go back to the previous page where we talk about the Law of Detachment, the Law of Syllogism, before we talk about those, really I would be remiss if we didn't talk about conditional statement first. So let's talk about a conditional statement, and then I'll go back to that previous page. So here's the idea with a conditional statement. What you've got is a conditional statement, generally statements that involve the use of if and then. These are what we'll call a conditional statement. I have a perfect example right here. If it is raining, then I will use an umbrella. Please look at this. Here's what you got. You have if. Oh, sorry, hold up. That's my highlighter. Yuck, 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 yuck. You have if P. Then we'll use an arrow Q. So if it's raining, then I will use an umbrella. This is a conditional statement. The first part is what is known as the hypothesis. Hypothesis. The first part is what is known as the hypothesis. That's the P. If something. If it's raining. That's my hypothesis. If it's raining. The conclusion then is going to be the Q. This is my conclusion. So, if hypothesis, then conclusion. If it's raining, then I will use an umbrella, right? And we will write that P, then Q. If P, then Q. These are conditional statements. Now, what I'm going to ask you are the following conditional statements. We're going to learn a couple of things about conditional statements here as we do these. First of all, here's what you're looking for, right? If it is Tuesday, fantastic. There is my if P. And, then, Phil plays tennis, Q. So, if P, then Q. Conditional statement? Absolutely, yes. If it's Tuesday, then Phil plays tennis. Let's keep going, let's try the next one. 3 points that lie on a line are collinear. Is this a conditional statement? Careful. Just because a conditional statement generally, check the definition above, generally uses the word if and then, does not mean that it has to use the word if and then. In fact, you could put an if and then in here and still have the same statement. Check this out. If 3 points are on a line, then they are collinear. So the idea here is this. It is still if P, if 3 points lie on a line, then Q. What colors did I use above? Red and green. Right here. Look. My hypothesis. If 3 points lie on a line, then they are collinear. I have a hypothesis. I have a conclusion. Even though I didn't use if and then, doesn't matter. Still a conditional statement. So the idea here would simply be this. It does not have to use if or then. Okay? Still possible that it is a conditional statement, even if the words if and then are not there. But if you can put the words if, right, if you reread it, kind of redo it in your head, and you can put the if and then in there, fantastic. As long as you have a hypothesis and a conclusion. Conditional statement. The last one. You are at least 21 years old if you are an adult. Conditional statement? Actually, yes. Something else to watch out for here. Look at this. If you are an adult, that's if P, then Q, then you are at least 21 years old. But please look at what's happened. The hypothesis and the conclusion have switched places. That's okay. Now, we have a special name for when this happens, right? When the hypothesis and the conclusion have switched places, we're going to call that something special, which we'll look at on a later page of the notes. It's actually something we've already talked about. It's called a converse statement. We'll go over that again in a second. But this is still a conditional statement, still conditional. we can switch the hypothesis and the conclusion. It'll still be conditional. We just have a special name for it. We can switch the hypothesis and the conclusion. We can switch those guys. Perfectly okay. Still a conditional statement. We'll have a special name for when those guys get flipped, but it's still a conditional statement. Okay, here we go. I just want you to write the following as conditional statements if it's possible. Adjacent angles have a common vertex. Okay, so if-then statement, right? If you have adjacent angles, then they will have a common vertex. We'll call it AA. If adjacent angles, then common vertex. I'm really shorthanding that because sometimes it's a little hard to read my writing. Here's what I would say. If you have adjacent angles, then they have a common vertex. That's an if-then, hypothesis, conclusion. Glass objects are fragile. If an object is glass, then it is fragile, right? If an object is glass, then it is fragile. An angle is obtuse if its measure is greater than 90 degrees. So, if an angle is obtuse, then its measure is greater than 90 degrees. Okay, so if, then conditional statements. All right, conditional statements. If P, then Q. Okay, so now that we know something about conditional statements, go back to the previous page, right? The law of detachment. These are ways of deductively reasoning to a conclusion. Here we go. The law of detachment. Here's what it says, all right? If P, then Q is true. So I have this conditional statement. If P, then Q. We just saw conditional statements. We just talked about them. If P, then Q. If P is true, then Q must also be true. And I know what I just said. There are a whole bunch of words. Stick with me. Take a look at this example. It'll make perfect sense. Here we go. Here's my conditional statement. If a student gets an A on the final exam, then the student will pass the course. Look at this. If, right? If P, then Q, right? If a student gets an A on the final exam, then the student will pass the course, right? If then, conditional statement. Now, here's what we have. David receives an A on his geometry final. So, thanks to the law of detachment, deductive reasoning says what? If a student gets an A on the final exam, then they will pass the course. David receives an A on the geometry final. Deductive reasoning says David will pass the course. As long as if P then Q is true. As long as this statement is true. And as long as P is true, then Q, by deductive reasoning, must also be true, right? That's what this says. If P then Q is true and P is true, then Q must also be true. So I've given you an if P, then Q, if that's true. And if P is true, David gets an A on his geometry final, then Q must also be true. Then David will pass the class, all right? One more. Let's try another one. Two numbers are odd. If two numbers are odd, then their sum is even. Do you see it? Right? This is if P, then Q, right? Which is a true statement. If two numbers are odd, then their sum will be even. That is true. True, true, true. Very, very true, right? So now, what else am I given? 3 and 5 are odd numbers. Here's my P, and guess what? That also is true. 3 and 5 are odd numbers. Deductively, by deductive reasoning, the law of detachment, what can I say? The sum of 3 and 5 is even. Now, as long as my conditional statement is true and P is true, the law of detachment says that this must be true as well. And it is. We know that 3 plus 5 is 8. 8 is an even number. So, using deductive reasoning and the law of detachment, we can prove something to be true because the facts, right? I'm using this fact, which is true, and this fact, which is also true, to come to a conclusion. And since my facts are true, my conclusion must also be true. Okay? Now, the law of syllogism, also based on deductive reasoning. All right? The law of detachment, deductive reasoning to come to a true conclusion. The law of syllogism, again, based on deductive reasoning to allow you to come to a true conclusion. And here's the way that this one works. Actually, if you think about the transitive property from algebra, remember the way the transitive property works? I have it for you right here. If A is equal to B, and if B is equal to C, then what do I know? A equals B, B equals C. Well, yeah, A equals C, right? That's the transitive property, right? Well, here's the way that this is going to work, right? It's the law of syllogism is the same thing. If P, then Q. If P, then Q. And if Q, then R. Do you see this? If P, then Q. If Q, then R. So the law of syllogism, like the transitive property, says what? Well, cut out the middleman. Get rid of the Q and you can simply go if P, jump all the way to the end, then R. Let me show you. If M is the midpoint, if M is the midpoint of segment AB. So here's what you've got. You have if P, then Q, right? If P is the midpoint of segment AB, then AM, that segment AM, is equal to MB, right? That is the definition of midpoint. That's our definition, okay? Keep going. If the measure of two segments are equal, that's exactly what I said right there. AM is equal to MB. This is if Q. Then they are congruent. Then R. What are we going to do? Cut out the middleman. Cut out the middleman. We get rid of the Q, right? And based on the law of syllogism, I can say this. If M is the midpoint of segment AB, if M is the midpoint of segment AB, then they are congruent, right? That law of syllogism allows you to cut out the middleman and put your original hypothesis with your final conclusion. Hypothesis, conclusion. Another hypothesis, my final conclusion. Cut out the middleman, original hypothesis, final conclusion. All right, that's the way that the law of detachment and the way of law of syllogism both use deductive reasoning to help you prove something. As long as the facts you're using are true, then your conclusion must be true based on deductive reasoning. All right, we're going to head on over to the next page of the notes. We're going to look at some other ways of writing conditional statements, and then we'll jump into proofs. So head on over to the next page of the notes. I'll meet you guys there.